That's one small step for man, one giant leap for mankind.
That was the voice of astronaut Neil Armstrong, who, along with Buzz Aldrin and Michael Collins, was part of the Apollo 11 mission, which landed the first humans on the moon. Since time immemorial, humans have been fascinated by what happens in the night sky. The desire to understand the unknown, combined with the intelligence and resourcefulness of our species, has brought us closer to understanding the universe around us. Welcome to the first episode of Celestia's Guide to the Universe. Before we explore the vastness of space, we spark our inquisitiveness by looking at a celestial object that is distinctly visible from the Earth itself, the Moon. The Moon is the most prominent object in the night sky and has been a topic of interest for centuries. From 450 BC, when Anaxagoras hypothesized that the Moon reflected the Sun's light, to 1969, when the first humans to land on the Moon departed from the Earth. This was a historical landmark for space travel and exploration. But how exactly did we accomplish this marvelous feat? What pushed us to travel beyond the horizon and into the darkness of space?
Fueled by the beauty of the Moon and the curiosity to know what lies beyond, the space race began back in 1955. This space race was done to prove the might of the nations, but it resulted in many scientific boons. The multiple moon orbital launches quickly and cumulatively helped to map almost 99% of the Moon's surface. The Surveyor 6 moon lander in 1967 then confirmed if the Moon's surface was solid. Consequently, the Surveyor 7 moon lander successfully tested the method to melt moon rocks. These missions paved the way for Apollo 11, the first human moonwalk. The astronauts spent 21.5 hours on the Moon's surface and carried out multiple experiments to study the different properties of the Moon. But perhaps the most important task was to collect 22 kilograms of lunar samples and bring them back to Earth. Apollo 11 was the first of many successful moonwalks, after which 5 triumph exploration missions took place in the form of subsequent Apollo missions. Collectively, these brought back about 2200 samples weighing almost 382 kilograms, helping us decipher the lunar soil, or the lunar regolith.
Although we now know what the Moon is made of, we are still unsure of how it got there. Several hypotheses have been proposed of how it may have been formed, the most acceptable of which is the giant impact theory. This theory hypothesizes that when the Earth was still forming, that is, when it was still just a lump of hot rock known as the proto-Earth, another Mars-sized object, which we dub as Theia, collided with the proto-Earth, resulting in a massive explosion which threw debris from both the planets into orbit around the Earth. As time passed by and the Earth cooled, the debris coalesced into what we know as the Moon today. The most noteworthy evidence to support this hypothesis is that the Moon and the Earth have similar radioisotopic ratios in their rocks. But even with such strong evidence, we still have no concrete idea as to how the Moon was formed, as there still exist multiple hypotheses for the same. Nevertheless, this is our favorite theory, because it describes a crucial aspect of the Moon's surface. As in this case, a slowly cooling Moon orbited a still molten and unbearably hot Earth, and as tidal locking was achieved, one side of the Moon was continuously baked by the relatively hot Earth, leading to the far side of the Moon to cool down much faster and form a thicker crust relative to the nearer side.
The Moon's crust, unlike ours, isn't covered with trees, oceans, mountain ranges, or even people. The most common surface feature of the Moon are its craters. These are ball-shaped landforms formed by violent volcanic activity and cratering processes that have shaped the Moon's surface since its formation. The largest crater on the Moon is insanely huge. It stretches across nearly a quarter of the Moon and is called the South Pole Atkin Basin. It also happens to be the Moon's oldest impact basin, formed almost 3.9 billion years ago. Another interesting structure of the Moon are lava tubes. These are structures produced by underground flowing magma from ancient volcanoes which are leaking out onto the surface. Once the flow of lava diminishes, the tube may drain, forming a tube-shaped passage. The mantle of the Moon is far more extensive than the crust. Below the mantle is the Moon's core. The inner core is a solid mass. Surrounding the solid inner core is a fluid outer core. The Moon has a dense metallic core, largely composed of iron and small amounts of sulfur and nickel. Now, even though we know a lot about the structure of the Moon, a portion of it is still locked away. The far side, popularly but inaccurately known as the dark side of the Moon, it is that side which always faces away from the Earth.
The first images of the far side of the Moon were sent back by USSR's Luna 3, and these were in stark contrast to the images of the near side. Densely peppered with impact craters varying in both size and age, the crust on the far side is thicker than that of the nearer side. When you look at the junction between the nearer and far side, there exists a peculiar region, the poles of the Moon. Currently a hot topic for future lunar exploratory missions, the poles of the Moon are unique environments which preserve a surprising record of some volatile substances on the lunar surface. Among these, water is what piques our interests the most. Well, why water, you say? You can drink that. Use it to grow plants, for food, separate H2O into hydrogen and oxygen and then use it to breathe. Combine them back together and then you have rocket fuel. And in some cases, you can use water directly as a propellant. Most importantly, water is a fantastic shield against radiation. Hiding under the surface of water ice is as safe as being on Earth. The surface of the Moon is constantly exposed to charged particles of solar winds as well as galactic cosmic radiation. The radiation levels on the Moon's surface are 100 times that of the Earth. If you're wondering why, then you might want to consider the absence of an atmosphere on the Moon's surface. The radiation that hits the Moon's surface is enough to instantly sublimate any phase of water that might be present. But there are a few regions which might have had water reserves for millions of years. The permanently shadowed craters of the Moon's poles.
During the lunar day at the equator, the temperatures reach up to 125 degrees centigrade, and during the lunar night, the temperatures go as low as negative 173 degrees centigrade. But near the poles, the minimum temperature is about 50 degrees colder. There is quite a simple reason for that. The spin axis of the Moon is nearly perpendicular to the ecliptic, which is the plane in which the Moon orbits the Sun. So, the Sun always appears just at the horizon at the poles, casting long shadows across the lunar surface. And the deep craters surrounding these poles will have a complete absence of sunlight in the depths. The temperatures of these permanently dark areas were found to be extremely cold, never reaching a surface temperature greater than about 25 to 30 degrees above absolute zero. These are the regions having the highest possibility of having deposits of water. In fact, research has shown the presence of relatively pure water ice meters thick inside. At the southern pole, most of the water ice is concentrated at lunar craters, while the northern pole's ice is more widely but sparsely spread and mixed with the lunar regolith. When it comes to the Moon, we have a lot of data. However, certain aspects of the lunar surface still haven't been verified and mapped in detail. Space programs worldwide are assessing possibilities of lunar exploration, which involve equipping satellites and surface rovers to determine the nature and extent of the hidden lunar regions.
Over the next few years, we will see the launch of more than a dozen different lunar missions. Some will just orbit or loop around the Moon, some will make contact with its surface, while others will be tasked with deploying rovers and robots for deeper exploration. The Artemis mission by NASA is the forefront of lunar exploration. Many other countries and private companies are eager to get in on the excitement. It's all about exploring possibilities and expanding our knowledge of what lies beyond us.